integration of the two function in terms of product is nothing but first function into integration of the second minus integration of the second into derivative of the first function. So for some reasons it is not possible to integrate the value whenever the powers of x is in the form of x to the power n. See, if f of x is 1 plus x square, what is f dash of x? What is the derivative? It is 2x dx. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in this session, we are continuing with the integrations of functions, and here in this session, we are going to study about the integration by parts. So in differentiation, you have learned the product rule as well as quotient rule whenever the two functions are in a product form or a quotient form, that is in the form of f of x by g of x. Now here, suppose when two functions are in product form, then how we are going to integrate with respect to x. So here is a rule which is called as integration by parts. Now suppose you have two functions f of x and g of x, and when you are going to integrate with respect to x, how we are going to write the function with integration. So the rule says first function integral of the second function with respect to x minus integral of second function into derivative of the first function. So this is, read it as, see, the integration of the product of two function is first function. So whatever the first function, you write it as it is. So along with first function, you integrate only the second function. Then minus integral of, so you have double integrals here. So integral of, what you have to take, again integral of second function into derivative of the first function. So after integrating second function, you will get a value. After differentiating first function, you will get a value. So again, one more time, you are going to integrate it outside with respect to x. So this is the rule which is called as integration by parts. So how we will study is integration of the two function in terms of product is nothing but first function into integration of the second minus integration of the second into derivative of the first function. So this is called as the integration by parts. So now sometimes what happens, so suppose we have x into sin x. So x into sin x. So however we are going to integrate, we can choose any one of the function as f of x, any one of them as a second function. So here what happens if you integrate it? So what happens? Apply the rule. If this is your first function and this is your second function, what does the rule says? First function into integral of the second minus integral of, so within the square brackets, I'll again write minus integral of second function with respect to dx into derivative of the first function, which is x. So this is with respect to dx again. So how we are going to write it now? Now integrate. First function. What is integral of sin x? Integral of sin x is minus cos x. So this is done. Again minus integral of, what is integral of sin x? It is minus cos x. And what is derivative of x? It is 1. So with respect to dx again. Now this is minus x cos x. And here minus, if you take outside, plus. What is integral of cos x with respect to dx? Sin x plus c. So this is the integral value. So by choosing any one as the first function or any one of the second function, so this is what happens. Suppose if I choose sin x as first function, x as second function, let me see what happens. Now the same function, I will write sin x as the first function, cos x as the second function. Now let us apply the integration by parts. So this is your first function, this is your second function now. So therefore what does the rule says? First function integral of the second minus integral of the second into derivative of the first function, that is derivative of sin x with respect to dx. Now let us take it. Sin x, what is integral of x? X square by 2 minus, again here, what is integral of x? X square by 2. What is derivative of sin x? It is cos x into dx. Now we have sin x into x square by 2 minus half outside. Again we are getting two more functions here with respect to dx. So again we have to apply integration by parts. So if you go on applying the integration by parts, again the power of x goes on increasing. If you take x square cos x, so again you have to derive it. So in this case also, if you choose again cos x as first function, x square as second function, the power of x goes on increasing, and again you will get the integrals in the product form only. So that is why you have to be very careful by choosing the first function. So the first function has to be chosen with the rule called LIATE. What is this LIATE? Suppose you have any function or any two functions f of x, g of x into dx. However the function may be given, choose the first function. So here choose u into v form, u dot v form. So choose u, that is the first function, always in the form. So whenever you have, choose u always in the form logs, give preferences to logs, then for inverse, then for algebraic, then for trigonometric, and finally the exponential function. Suppose if you have any integral of x log x into dx. Now you have to apply the integral here. So how to choose the first function? So according to this rule LIATE, log function has to be taken as the first function. So that is why you are going to write it in the form of log x into x. X is an algebraic function, so therefore you take it later. And now apply integration by parts, then you will get the integral value. Suppose if you have x tan inverse x. So you have to give preference for the tan inverse function because inverse comes after algebraic. So inverse comes before algebraic function. So therefore the first function has to be taken for tan inverse, and next you have to choose x function. So this is how you are going to choose the first function before applying integration by parts, and finally the exponential can be taken later. So for some reasons it is not possible to integrate the value whenever the powers of x is in the form of x to the power n. So that is why we apply this rule LIATE. So give preferences for log function, then inverse, then algebraic, then trigonometric, and finally exponential functions. So also you should know that there are some type of functions whose derivative can't exist. That is why we can't integrate the following also. For example, if I take sin x root x, sin x root x. So this is an example. If given to derive with respect to x, then since its derivative does not exist in the form of sin x root x, we can't integrate. So therefore, before integrating the function, you should also know the knowledge of does its derivative exist. And before applying integration by parts, you should know to choose which function has to be taken as u and which function has to be taken as v. So then only we can apply the integrals and finally find the integral values. So let's take up few problems. Integration of sin x dx. So here according to LIATE, which function has to be chosen first? Algebraic, then trigonometric. See, first algebraic, then trigonometric function has to be chosen. So the function is already given in an order. So let me apply the integration by parts. What does integration by parts says? First function, integral of second with respect to x minus integral of second with respect to dx into derivative of the first function with respect to dx. So coming to the second integral, you should be very careful. Again, write the second integral as it is and derive the first function. Now let us write it x. Derivative of sin x is minus cos x. Next we have minus. Again we will write the integral. What is integral of sin x? Minus cos x. What is derivative of x? It is 1. So cos x into 1 with respect to dx. Minus, if you take outside, it is minus x cos x, minus into minus plus. Integration of cos x with respect to dx is sin x plus integration constant. So this is the integral value. Next, integral of e power x square dx. Exponential function has to be given opportunity at the last. So therefore algebraic comes first. We will write this in the form of integration of x square into e power x dx. Now apply integration by parts. So first function, integral of second minus integral of second into derivative of first function, that is x square, into dx. So now here x square, what is integral of e power x? It is e power x only, minus here, what is integral of e power x? It is e power x again. What is derivative of x square? It is 2x with respect to dx again. Let me take 2 outside. We have x square e power x minus 2 times, here again we have e power x into x, a product form. So let us write into x into e power x. Let us apply integration form with respect to dx. Again we have to apply integration by parts. So x square into e power x minus 2 times. What does the rule says? First function, integral of second minus integral of second into derivative of first with respect to dx. So here you have x square e power x minus 2 times. So x into e power x. Now integral of e power x is e power x. Derivative of x is 1. Again integral of e power x becomes e power x only. So therefore evaluate, derivative of x is 1. So 1 into e power x is e power x. Integral of e power x is e power x. Again integral of e power x is e power x only. So therefore this is e power x plus c. So there exists some function where we have to apply the integration by parts in the second integral also. So but since the power of x goes on increasing, we can apply the integration by parts. Whenever the power of x goes on increasing, we can't apply integration by parts because it has to be applied n number of times, which is not possible. That is why algebraic function has to be chosen first and later the exponential function. Next one we have x log x. So what has to be chosen first? Log has to be chosen first. So therefore we take it as log x here into x with respect to dx. So what does it says? First function into integral of second, that is x dx, minus integral of second into derivative of first. Outside you have to write dx. So log x into x square by 2 minus, here we have integral of x dx is x square by 2 into derivative of log x is 1 by x with respect to dx. So x cancels. We have log x into x square by 2 minus, let me take half outside, you have integration of x into dx. So again log x into x square by 2 minus 1 by 2. So what is integral of x dx? Again it is x square by 2 plus c. So if you can take out x square by 2 outside, it is x square by 2. So we have log x minus 1 by 2. So log x minus 1 by 2 plus c. You can also evaluate. You can write it in the form of 2 log x minus 1 divided by 2. Next we have x square into log x dx. Again we are going to choose it in the form of log x into x square dx. So let us apply the rule. First function integral of second minus integral of second derivative of first function. So with respect to x. So log x square is given, means it is x cube by 3 minus integral of x cube divided by 3 into 1 by x with respect to dx. X cancels here. So we have here log x dot x cube by 3 minus 1 by 3 I have taken integral of x square dx again we get. So we have log x into x cube divided by 3 minus 1 by 3 into x cube divided by 3 plus c. So integration of x square is x to the power 3 by 3. So you can take x cube as a common factor. So x cube, if you take as common factor, divided by 3. If you take x cube by 3 here, you will get log x minus 1 by 3 plus c. Or you can also write it in the form of, so if you take, it will become x cube divided by 9 into 3 log x minus 1 plus c. So this is also can be written. So 3 into log x minus 1 divided by 3, 3 3s are 9. So it can also be written as x cube divided by 9, 3 log x minus 1 plus integration constant. Next one. So x into secant square x. This is already given. So first algebraic and then trigonometric. So let us take this first function integral of second minus integral of second into derivative of first x with respect to dx. So what is integral of secant square x? Tan x minus integral of, what is integral of secant square x? Tan x. What is derivative of x? It is 1. So tan x into dx. Now again we have x tan x minus, what is integral of tan x? What is integral of tan x? It is log of modulus of secant x plus c. So this is the integral value. So next we have integral of tan inverse x and with respect to dx. So how to integrate it? So whenever only single function is given, take another function as 1 into dx. So here I will write this as tan inverse x into 1 with respect to dx. So now let us apply the integration by parts. So it says first function into integral of second minus integral of second into derivative of first function. So let's write here tan inverse x. What is integral of any constant with respect to dx? It is x. So 1 into x, it is x minus integral of, so this is x into derivative of tan inverse x is 1 over 1 plus x square with respect to dx. Now here this can be written as x tan inverse x minus. Look at the second integral. This is of the form f dash of, so look at the second integral here. So this is, what I will do here, I will multiply 2 and I will take 2 as a common factor outside the integral with respect to dx. See here, this is in the form of x divided by 1 plus x square, right? So here I will multiply 2 to the numerator and I will divide by 2 and I will take it common. So it becomes 1 by 2, and when you multiply inside it will get cancelled and you will get back the same result. So here you can observe this 1 plus x square can be considered as f of x and this will become its derivative. So now this function, it is in the form of integral of f dash of x divided by f of x with respect to dx. See, if f of x is 1 plus x square, What is f dash of x? What is the derivative? It is 2x dx. So this is of the standard form, f dash of x by f of x dx. So how this can be written? This can be written as log of f of x plus constant. So which is the standard form we have learned, and hence this can be written as x tan inverse x minus 1 by 2 log of modulus 1 plus x square plus c. So this is the answer. Or if you don't know the standard form, you can use the substitution method. Put t is equal to 1 plus x square, then dt is 2x dx. So again this is in the form of dt by t. Integral of 1 by t is log t. What is t we have taken? We have taken t as 1 plus x square. That is why it becomes log of 1 plus x square. So either you can use the standard form if you remember, or you can use the substitution method and find the integral, which will result with the same value. Next we have x into tan inverse x. We have algebraic and inverse. So what has to be come first? First we have to take inverse and then algebraic. So L-I-A-T-E. This is the rule. So now we'll take this as tan inverse x into x with respect to x. So therefore now first function tan inverse x, integral of second, that is x into dx, minus integral of second into derivative of tan inverse x with respect to dx. Now here we have tan inverse x, this is x square by 2, and here integral of this is x square by 2 into derivative of tan inverse x is 1 over 1 plus x square with respect to dx. So I'll take 2 outside. So tan inverse x into x square divided by 2, and here I'll take 1 by 2 outside. Numerator, you can observe we have x square. So let me add 1 and let me subtract 1. 1 plus x square with respect to dx now. So now I'll separate these two functions. So here we have x square by 2 into tan inverse x minus 1 by 2. So divide this. This becomes 1 plus x square cancel. So this is 1 minus, and here we have 1 divided by 1 plus x square. So with respect to dx. So what we got there, that is x square by 2 into tan inverse x minus 1 by 2 integral of 1 minus 1 divided by 1 plus x square with respect to dx. So this is what we got after simplification. Now let us apply the integral. So x square by 2 tan inverse x, we have half outside. So into, so we have integral of 1 into dx minus integral of 1 over 1 plus x square into dx. So now what is the integral of the form x square plus a square with respect to dx? It is 1 by a tan inverse x by a plus c, correct? Or you know that derivative of tan inverse x is 1 divided by 1 plus x square. So obviously integral of 1 by 1 plus x square has to be tan inverse x. So therefore here it is x square by 2 tan inverse x minus integral of 1 is x. So this becomes x divided by 2. Next again we have minus into minus plus, and here what is integral of 1 by 1 plus x square? It becomes tan inverse x, or you can use this rule. So here the value of a is 1, so therefore it is tan inverse x again. So therefore it is 1 by 2 tan inverse x plus c. So this is the value of the given integral. So look here, so you have x into tan inverse x. First write inverse trigonometric and then algebraic function. Apply the integration by parts. So you will get it as x square by 2 1 plus x square. Now since these type of integrals does not exist, we will make or reduce it into one of the standard form. Do that. What I will do here, I will add 1 to x square and I will subtract 1 to x square. Then there will be terms in the numerator. So divide each term separately by the denominator. So 1 plus x square cancels. It gives you 1. And here it becomes 1 divided by 1 plus x square. So after applying the result, this is what we get now. Now the first term is done. Second term we have half as a common factor. Apply the integral separately. Integral of 1 into dx is nothing but x. X into 1 by 2 becomes x by 2. Next, minus into minus is plus. 1 by 2 we have. Integral of 1 over 1 plus x square is tan inverse x plus integration constant. So this is what the integral value of x into tan inverse x. So I hope you understood how we are going to evaluate with the help of integration by parts. We'll take up few more problems in our next session. Until then, keep watching, keep learning, keep exploring. Thank you.